This is Seth Byer, section 021. And this is Lab 7, problem 3, creating a tic-tac-toe game. So, just explaining the code really quick. We create our Arduino variable, which we'll need and able to control the potentiometer and the two buttons. I believe it goes right, left, by the way that you'd be facing. This is how I usually face it. Then you create the XY tables that will graph the X and the O's in the tic-tac-toe table. Configure your pins, and then this is a function that I made just to do all the fast moves, since it's easier to just put one line instead of compared to 18 lines. Then I have all these directions that say that the farther to the right you turn, like if you turn it all the way to the right, it'll be the top row, turn all the way to the left, it'll be the bottom row, put in the middle, it's the middle row. The right button determines the right column, the left button determines the left. If you don't do anything, it'll be put in the middle. And basically like the timing for it all and all that junk. And then I made a while loop for all of this code for the tic-tac-toe game for when either the read digital pin of this button or not an and, or this button is equal to 0. And since neither of these buttons will technically be pushed at the same time, this loop will continue on forever. Or until you hit them both at the end, and then obviously it just stops. And then what I like to do is I did an if loop with the read voltage of the potentiometer. If it's less than 1.5, aka all the way this way, then it will move on to the next part, which will be determining the column, and then it takes the button, and depending on where the button puts it is where it'll be in the top row, because I have these draw tick commands right up here, which is making the X. I have draw tick for X and draw talk for Y, or for the O's. And I used the code for the draw X and the draw O from the previous lab. All I did was I added the X start and I added a Y start, and I just add those onto the coordinates, so it will literally fast move to the coordinate and then draw it right there in the spot. And then going back to the lab, you can see that depending on where it is, it puts it at a certain position. So say this is top row, and I want it over to the right, then it'll graph it at 9, 8, which would be the top right part of the XY table. And then I have it for the, for if it was in the middle right here, this would be the middle row. It does the same stuff with the X, and then it goes over, if it was right here, then it would be the bottom row. And then it does the stuff with the buttons and the X. And then I do the same exact thing. The only difference is I have a draw tack instead of draw tick. This indicates that an O is up next. So the X is start and then followed by the O, and then it just goes all the way through. So just a little example of it. So it creates a tic-tac-toe table. The one problem I did have with this lab, however, is you will see I cannot figure out how to create this table and then put the fast move with the functions that I made onto this. Since they're two functions, I'm sure that if you took the functions and put them in here, you could, I guess. I don't know why I didn't. You could do that, and that would probably graph it better, but I just like these function commands, so it's short, sweet, and to the point. And then as you can see, it's going to start, it asks which row and then which column, and then it creates the X, and then if I move this, it asks row, column. I'm going to put this O in the top right, and then I'll put this next X, ask row, it says X, and then row, column, this will be top middle. I'll put this next O in the bottom left. And then just create the tic-tac-toe with putting the X in the middle row on on the middle column in the bottom row. And that's it.